Billions of miles from the sun, Pluto drifts in the deep freeze of space, orbiting at the very edge of our solar system. Out here, sunlight is faint, and the temperatures plunge to hundreds of degrees below zero. For much of human history, Pluto was a world long shrouded in mystery, hidden in the darkness, barely more than a whisper in the cosmic night. For decades, it was just a blurry dot in our telescopes, the enigmatic ninth planet, then reclassified as a dwarf, always on the edge of discovery, sparking debates and curiosity among astronomers and dreamers alike. But in July 2015, everything changed. NASA's New Horizons probe, after a journey of nearly a decade and over 3 billion miles, finally reached Pluto, sending back images and data that stunned the world and rewrote the textbooks. Suddenly, Pluto was revealed as a place of breathtaking complexity, towering ice mountains as tall as the Rockies, vast plains of frozen nitrogen, and a giant heart-shaped region known as Tomball Regio, named for Pluto's discoverer. This wasn't a dead, frozen relic at the edge of the solar system, but a dynamic world with a story to tell, one that surprised even the most seasoned scientists. Imagine standing on Pluto. The sun is just a bright star in a black sky, casting a faint glow over a landscape of nitrogen glaciers that stretch for hundreds of miles, under a sky filled with distant stars and the faint glow of the Milky Way. New Horizons images were a revelation, showing a geologically alive world with evidence of shifting ices, possible cryovolcanoes, and a surface marked by both ancient craters and fresh, youthful plains. We expected a frozen fossil, but instead found a vibrant dwarf planet with its own unique personality, full of color, contrast, and unexpected activity. Pluto's close-up was like meeting a stranger and discovering a fascinating new friend, one with secrets, quirks, and a beauty all its own. This encounter reminded us that the universe is filled with wonders, even in the darkness at the edge of our solar system, where we least expect to find them. Pluto, once a distant point of light, became a real place. Mountains, valleys, plains, and perhaps even a hidden ocean beneath its icy crust, hinting at the possibility of something extraordinary below the surface. Its secrets invite us to look deeper, to wonder what else lies beyond, and to ask bigger questions about our place in the cosmos, reminding us that exploration is far from over. To truly understand Pluto, you must first grasp the staggering scale of its distance from us, nearly 4 billion miles from the Sun, far beyond the familiar planets, nestled in the icy expanse of the Kuiper Belt. This remote region is a vast ring of frozen worlds and mysterious objects, stretching beyond Neptune and marking the edge of our solar system's known frontier. Sunlight, which takes just over 8 minutes to reach Earth, must travel for more than 5 hours to touch Pluto's surface. By the time those rays arrive, they are so faint that Pluto exists in a state of perpetual twilight, its landscape bathed in a dim, ghostly glow. Temperatures here plunge to a bone-chilling -387 degrees Fahrenheit, making it one of the coldest places in our solar system. Pluto's journey around the Sun is unlike any other planet's. Its orbit is a stretched oval, highly elliptical and tilted compared to the rest of the planets. Sometimes, this odd path even brings Pluto closer to the Sun than Neptune, a rare cosmic dance that lasts for decades. Its unusual orbit, combined with its tiny size, Pluto is smaller than Earth's moon, sparked decades of debate among astronomers about whether it truly deserved to be called a planet. In 2006, after much discussion and scientific scrutiny, Pluto was officially reclassified as a dwarf planet by the International Astronomical Union. This wasn't because Pluto lacked importance or fascination, but because it hadn't cleared its orbital neighborhood of other debris, a key requirement for full planetary status. Rather than diminish Pluto's significance, this new classification only made it more intriguing. Pluto became the king of the Kuiper Belt, a region teeming with icy bodies and ancient relics, and a window into the solar system's distant past. Dwarf planets like Pluto are not just leftovers. They are time capsules from the solar system's formation, preserving clues about the building blocks that shaped our cosmic neighborhood billions of years ago. By studying Pluto, scientists can explore the incredible diversity and complexity of our solar system, uncovering secrets about how planets, moons, and other worlds came to be. Pluto's reclassification highlights the richness of our solar system, reminding us that it is filled with unique and fascinating worlds, each with its own story to tell. The story of Pluto is not just about one small distant world, but about the history and evolution of our entire planetary system, a story still being written as we explore further. By exploring Pluto, we open a window into the early days of the solar system, gaining insight into the processes that shape the planets and the mysteries that remain. Pluto's long, lonely journey reminds us that the cosmos is more diverse, more mysterious, and more wondrous than we ever imagined, inviting us to keep searching, learning, and dreaming about what lies beyond. Sending New Horizons to Pluto was one of NASA's boldest missions, a 9.5-year, 3 billion-mile journey. Launched in 2006, it was the fastest spacecraft ever, yet still took nearly a decade to reach its target. For most of the trip, the probe slept in electronic hibernation, waking only for check-ins. In July 2015, New Horizons raced past Pluto, gathering terabytes of data in just hours. The data took over a year to reach Earth, revealing Pluto's thin nitrogen atmosphere, weather patterns, and a heart-shaped glacier. We saw flowing ice mountains and a surprisingly active surface. Pluto was not a frozen relic, but a geologically dynamic world. The mission proved that even the most distant corners of our solar system hold incredible surprises. Pluto, like Earth, has a layered structure, but with a twist. At its core lies dense rock surrounded by a possible subsurface ocean of liquid water, kept warm by radioactive decay. This hidden ocean could be over 60 miles deep, with more water than all of Earth's oceans. Above, Pluto's crust is made of rock-hard water ice, topped with frozen nitrogen, methane, and carbon monoxide. Volatile ices act like a weather system, reshaping the landscape over time. The slow churning of the subsurface ocean may crack the icy crust, driving Pluto's geological activity. Understanding Pluto's anatomy helps explain its mountains, plains, and dynamic surface. This distant world structure is key to unlocking its secrets in evolution. Pluto's most iconic feature is the heart-shaped Tombaugh Regio, a vast, bright expanse that immediately catches the eye. This region is named in honor of Clyde Tombaugh, the astronomer who discovered Pluto in 1930, and it has become a symbol of the dwarf planet's mysterious allure. The western lobe of this heart, known as Sputnik Planitia, is a massive, smooth basin stretching over 1,000 kilometers across. It stands out as one of the youngest and most dynamic surfaces in the entire solar system, with very few impact craters visible. Sputnik Planitia is actually a gigantic glacier made almost entirely of frozen nitrogen. Its surface is divided into large, polygonal cells, shaped by the slow, churning motion of convection beneath the ice. Like a pot of thick soup, gently simmering over time. This constant movement of nitrogen ice acts like a natural resurfacing machine, erasing old impact craters and giving the plain its remarkably youthful appearance. The landscape here is always in flux, shaped by forces deep within Pluto. Encircling Sputnik Planitia are dramatic ranges of water ice mountains, some soaring as high as the Rocky Mountains on Earth. These rugged peaks are made of water ice, which is as hard as rock in Pluto's frigid temperatures. Remarkably, these mountains float like giant icebergs in the softer, denser sea of frozen nitrogen, drifting slowly over geological timescales. Beyond the heart, Pluto's surface is a patchwork of older, more varied terrain. There are yellowish polar caps, ancient cratered highlands, and vast, dark, reddish regions, such as the mysterious Cthulhu Macula. The dark material coating these regions is made of tholins, complex organic molecules formed when sunlight and cosmic rays interact with Pluto's thin atmosphere, creating a rich tapestry of color and chemistry. All these features together reveal Pluto as a world of stunning contrasts, where ancient, battered landscapes exist side by side with smooth, youthful plains, and where change is still ongoing. Pluto's landscape is a living record, preserving evidence of both its ancient past and its surprisingly active present, making it one of the most fascinating objects in our solar system. New Horizons revealed Pluto as a geologically active world, not a frozen fossil. Sputnik Planitia's young, crater-free surface and convection cells show ongoing internal motion. Pluto may even have cryovolcanoes, ice volcanoes that erupt water, ammonia, or methane. Features like Right Mons suggest recent eruptions of icy lava. Evidence points to a subsurface ocean, kept liquid by internal heat and ammonia. Pluto's activity challenges our ideas about what makes a world alive. Even far from the Sun, Pluto is a dynamic system, expanding our search for life in the cosmos. Pluto is not alone. It's orbited by 5 moons, the largest being Charon. Charon is half Pluto's size, making them a unique binary system, orbiting a shared center of mass. They're tidally locked, always showing the same face to each other. This relationship has shaped both worlds, possibly generating heat and influencing their geology. Charon's surface is scarred by vast canyons, hinting at a frozen, fractured past. Its dark polar cap, Mordor Macula, likely formed from gases escaping Pluto. Pluto's 4 smaller moons, Styx, Nix, Kerberos, and Hydra, tumble chaotically, likely born from a massive ancient collision. The Pluto system is a natural laboratory for understanding how planetary systems form and evolve. Each moon adds a new layer to Pluto's story. Together they reveal the complexity of the outer solar system. New Horizons answered many questions, but Pluto's mysteries remain. The source of its internal heat is still debated. Radioactive decay, or something else. The evidence for a subsurface ocean is indirect, confirming it is a top priority for future missions. Why is Pluto's surface so diverse, with bright plains and dark reddish regions? How did its bladed methane ice terrain form? A future orbiter could map Pluto in detail, probe for its ocean, and watch its seasons unfold. Pluto's story is far from complete. Its secrets are still waiting to be revealed. Pluto's story is a testament to human curiosity and the power of exploration. New Horizons transformed a distant dot into a world of wonder, expanding our view of what's possible. Pluto showed us that small, cold worlds can be geologically active, with hidden oceans and dynamic surfaces. Its discoveries force us to rethink where life might exist in the cosmos. The mission was a triumph of ingenuity and collaboration, inspiring a new generation of explorers. Space exploration pushes technology, fuels discovery, and unites us in wonder. By studying distant worlds, we learn more about our own planet and our place in the universe. Pluto's secrets are just one chapter in a much larger cosmic story. The journey to Pluto was a beginning, reminding us that the universe is full of light, waiting to be explored.